Okay, so for our next example, we want to write a program that determines whether a year is a leap year. So we can consider a year as a leap year if it is evenly divisible by 4 but not by 100, or if it is divisible by 400. So the second condition, where we check whether a year is should not be divisible by 100, is used to segregate the century years from leap years. So your century years are the ones with the zero zeros in the end. So for instance, 1300, 1500, 1400, and likewise. So, but a century year could be considered as a leap year if it is divisible by 400, in which we have added it here as a second, or as our third na condition. So how can we write it into code? So let's just check. Okay. So again, we want to determine whether a year entered by the user is a leap year. So we first declare a variable year, and then we prompt the user to enter year. Okay, and then of course we have to scan or store the value entered by the user in our variable year, or to the address of the variable year. So for the first argument, we add %d, and for the second argument, we add the ampersand followed by the variable na year. Okay, now we want to have our first condition is that the year is divisible by 4. Okay, so what we can do is we add an if na condition, and if your year is divisible by 4, we can do that by using the modulo operator or the remainder operator, where it computes for the remainder. So if your year is divisible by 4, meaning the result is 0. Okay, so it means that we can print that the year is a leap year. Okay, so then else printf the year is not a leap year. Okay, so let's try running our code, and we have to compile it first and then run. So let's try entering 2016. Okay, so we have listed here some examples that we can check whether our code is correct. So 2016 is a leap year. Yes, since it is divisible by 4 also. Does it also work for 2000? So it prints that yes, the year is also a leap year. Okay, so what if we put 1500? It writes that it is also a leap year, but we have specified in our examples that it is not a leap year. Why? Because we have another condition that the year is divisible by 4, but not by 100. Again, we want to differentiate your years from the leap years and the century years. If it is divisible by 100, it's a century year. Okay, so what we can do is we can also check that the year should be divisible by 4 and should not be divisible by 100. So what can we do is, again, use the modulo operator, and it should not be divisible by 100. So we can use our this operator for that. So we can add a parenthesis in order to make sure that the ambiguity is not present in our code. Okay, so let's check it works. Compile first. Okay, so let's enter 2016. Okay, so yes, it is a leap year. Is 1995 leap year or not? Yeah, it is not a leap year. Our code is correct. So let's enter 2000. Okay, it is not a leap year daw. Bakit? Why isn't it a leap year? Okay, so why is 2000 not a leap year? Because your 2000 is divisible by 4, divisible by, it is also divisible by 100, and it is also divisible by 100. But we have specified here in our example that it is a leap year, because even if 2000 is divisible by 100, it should be, it is also divisible by 400, which we consider as a leap year. So what we can do is we can add another, we can improve our condition, and we can add here another condition that checks whether your year is divisible by 400. Okay, so as you can see here, we have specified year is divisible by 0, but not by 100, but could be divisible by 400. So let's check whether it works now for 2000. Oh, okay. We have to compile our code first. Okay, so 2000. So yes, it returns now a correct answer. So it returns that your year is 2000 is a leap year. So, but if we observe our line 23, the line 23 is a bit difficult to read. So what we can do is we can separate the computations in a separate line. So with that, we can declare additional variables, let's say rem4, rem100, and rem400. So let's store in rem4 the result of this line that checks whether your year is divisible by 4. So checks if year is divisible by 4. Okay, now for, let's copy this one. And for rem100, where we check whether it's divisible by 100. Okay, so we can replace this with rem4 and this with rem100. And lastly, for the rem400, we can simply copy this and replace the expression with rem400. Okay, so now our code is shorter and much more easier to understand. Okay, so let's check. So, okay, now for 2016, yes, a year is leap year because it is divisible by 4, but not by 100. Now, let's enter 1995. It is not a leap year because it is not divisible by 4. And what about for 2000? It is not a leap year. It is a leap year because it is divisible by 4 and also divisible by 400. And 1800, yes, the year is not a leap year because it is evenly divisible by 100 but not by 400. And lastly, for 1500, the year is not a leap year because it is divisible by both 4 and 100. Okay, so that's all. Stop.